Alright, so in this video we're going to be going into unbiased estimators. So we propose the question: you have n independent samples of a normal distribution with an unknown mean mu and unknown variance sigma squared. And we're asked what unbiased estimators are there for mu and sigma squared. So what we're going to take advantage of is the maximum likelihood estimators, because the MLEs, for short, allow the ability to estimate parameters, which we have two of. And what we're going to take advantage of is if we take the expected value of these MLEs and they evaluate to just the parameter itself, then we know it is unbiased. So from chapter 5 we have these two equations for the maximum likelihood estimators for mu and sigma squared, and we're going to look at mu first. So first we just take the expected value of both sides, and we can pull out 1 over n from the summation because it doesn't depend on x, and then a summation from I to n. Depending on x, we can just pull out another n, and we find that the expected value of mu just equals mu. And that means we have an unbiased estimator. So that we don't need to do anything extra for. But we're going to find that the maximum likelihood estimator of sigma squared, in this case, is biased. So let's go into that. According to the textbook, sigma squared, a good maximum likelihood estimator, is 1 over n minus 1 times sigma I through n, summation I through n of x minus mu squared. So we found the expected value of both sides, and this is just a bunch of algebra and summation properties, but we factor out this inner part to expand the polynomial, and we factor out the common factor of 1 over n minus 1, and we find that we can simplify it to 1 over n times the expected value of the summation of x squared minus the expected value of the summation of n times mu squared. And finally, we can evaluate x squared in terms of sigma and mu, and we get to the point where we find that the expected value of sigma squared equals n minus 1 over n sigma squared. So if this was an unbiased estimator, the expected value of sigma squared would just equal sigma squared. But this isn't the case. We have this added constant. So we're asked to find the actual unbiased estimator. So what we can just do is we take our constant out, and we're just going to multiply by the reciprocal, because this will give us 1, and 1 times sigma squared is just 1. So if we just pull out the maximum likelihood estimator down here and multiply by the reciprocal of our constant, we finally get an unbiased estimator for sigma squared.